Okay, 5 questions that will be on the next SAT. And how do I know? Well, I don't. But the SAT is very repetitive. And these are all things that come up on virtually every SAT. So here we go. All of these questions are not actually from the SAT, but they're from this book, which is a great book. If you're looking for extra practice, you can get it on Amazon. It's got questions in every category that's found on the SAT by category and also by difficulty. So great for extra practice, no matter how you're studying for the SAT. But here we go. Our first question, x squared plus 7x plus 6 equals 0. If the solutions to the equation above are -7 plus or minus the square root of a over 2, where a is a constant, what's the value of a? What you might notice about this is it kind of looks like that quadratic formula. And that's what we're going to need here. Not only need to use it, but also we need to have this memorized. We need to use this on every SAT, but they do not give it to you. All of those formulas they give to you are geometry related at the beginning of the math section, but they do not give you this. But this is all we need to solve this. This is already in standard form, so the thing attached to the x squared is our a. In this case, 1. Our b is attached to the x, it's 7. And our c is the constant on its own, it's 6. And we just plug these numbers into the quadratic formula. We get -7 plus or minus the square root of our b squared minus 4 times our a times our c all over 2a. And we will end up with this -7 plus or minus the square root of 49 minus 24, which is 25. That will all be over 2. And we are left with what we saw in the question, -7 plus or minus the square root of something over 2. That something is our a. It looks like our a is 25. And that is our answer. All right, next question. The table above gives some values of the heights h in feet of several tall buildings and the corresponding cost to build C in millions of dollars. Which of the following equations models this relationship? What we notice from the answer choices is they are in that y equals mx plus b form. These are all in that slope-intercept form of a line. And what I notice is the slopes are all different, and that is how we can solve this. And another thing we need to have memorized for the SAT is how to find slope, which you might remember is change in y over change in x. And if we look at the answer choices, it looks like our y is actually c here, and our x is h. So it looks like it's change in c. So if we grab two c's, we can get 1015 minus 925 over our change in x, which is h. We got 1050 minus 915. And we'll end up with 90 on top, 135 on the bottom. If we plug that into our calculator, we get 0.6 repeating. It's 2/3. And it looks like A is the only one that has 2/3 as a slope. Our answer is A. All right, next one. We have a wrestler wants to put on weight for an upcoming match. He currently weighs 155 pounds and wants to increase his weight by 6% in the next 7 days. Which equation represents this situation in which W is a wrestler's weight in pounds and T is the number of days since he started gaining weight? And we'll see this equation on every SAT. Whenever we see a percentage increase or decrease, we will use this. In the first spot in the equation is always the initial amount. In this case, he initially weighs 155 pounds. That tells me A is not the answer here. Inside the parentheses, it's always 1 plus or minus the rate of change. So if it's a 6% increase, it would be 1 plus that 6% decimal, that's 0.06. We'd get 1.06, which tells me B is not the answer. And the exponent, that's always the amount of time. In this case, this 6% increase is happening every 7 days. When T is 7, that's when it needs to increase by 6%. It needs to be the first power when T is 7, which is telling me D is the answer. With D, when it's t over 7 as the exponent, when t is 7, it's to the first power. That's our first increase of 6% in 7 days, exactly what it tells us in the question. D is our answer. Our next question is circle equation. The graph in the xy plane of the equation above is a circle with a radius of a. What's the value of a? This, unfortunately, is not in the standard form where we can find the radius and the center. So we need to put it into standard form, which involves completing the square. First thing we need to do is group together the x's so we can make that a perfect square. We need to group together the y's to make that a perfect square. And we'll put the numbers on the other side. And then we need to complete the square. That always is having the middle term in squaring it. So having the 12 is 6, and squaring it, we get 36. That completes the square. Same thing with our next one. We have the middle term to get -2, and square that, we get 4. But I just added 36 and 4 to the left. I need to also add that 40 to the right. And then we factor, we group things together, and we get x plus 6 squared. We get a y minus 2 squared. And -24 and 40 will make 16. And now we can see the center is at -6, 2. Because the thing with the x always gives us the x coordinate of the center. The thing with the y gives us the y coordinate, but it's the opposite of what we see. The +6 gives us -6 for our x, -2 gives us 2 for the y. And then on the right side is r squared, meaning that if we take the square root of that number, we will get our radius, in this case 4, and the answer to this question is 4. And finally, one last question. We have the graph above in the xy plane is defined by f of x equals 3 to the x minus h power, in which h is a constant. What's the value of h? What we see here is an exponential graph, but this could be a parabola, it could be a line, it could be anything that's graphed on graph paper. Gives us points. Here I see 3, 1 as a point. I also see over here 4, 3 is a point. Both of these can give us the answer of what h is without having to know anything about the exponential graph and what h does to this graph. Instead, we can just plug in any point that falls on the graph in for x and y. So let's try 3, 1. 1 is our y, or f of x, means y when our x is 3, and we're left with this. So 3 to some power equals 1. Well, 3 to what power equals 1? That's to the 0 power. In other words, 3 minus h must equal 0. And if we solve for h, we'll find it's 3. But I could have done the same thing with the other point. We could have plugged in 3 for y and 4 for x. And now we'd have 3 to some power equals 3. What power is that? Well, 3 to the first power equals 3. So 4 minus h must equal 1. And again, if we solve for h, we'll get 3. Same thing. So D is our answer.